Hello and welcome to my final math assessment for the math game. I created the Math Path, which is basically a game that I digitally created because I wanted it to be a board game, but I wanted it to be in the cleanest format I could have it for what it would be an actual real life presentation. So I wanted to represent it in the cleanest way I could, which I figured would be this way. So my game is called The Math Path, and basically the idea of it is that students follow the math tiles, which are multicolored, representing certain types of equations and math problems that they have to solve, which are in the middle of the board. The left side of my screen is my board, and the right side is my game guide for the board. I wanted to create a board game because I love board games, and I felt like the multicolored and the bright colors would really stand out to students and make them want to play it. And it's a fairly simple type of game to follow, so I figured it would be good for students that are learning how to do their math currently, and that way they can focus more on the math itself rather than the rules of the board game, so it's not too confusing of aspects all at once. The game guide starts out with the title page of the Math Path game guide, and it shows how to play, which is to take turns to roll the dice and answer questions with equations, and the player with the most cards wins. It's 2 to 6 players, ages 9 or above. The contents are the instructions, the game board, dice, 6 peg pieces, and 150 multicolored cards, where each set of the colors of cards, so the red, green, orange, yellow, and blue, would have 30 cards per color for whoever has the game to keep track of the amount. I wanted the beginning of the pages and the words throughout the instructions to be fairly simple so it's easier to follow along. The second page of the game guide is the setup, which to begin setting up the game, you give each player a peg piece, which is represented in the photos below. And that's only a few of the colors. There are also a couple other colors, and there's extra pieces that would be provided in the game board as well. The next part of the setup is to place the game board on a flat surface with the colored game cards placed where they belong. So the red would be in the red spot on the board, the orange would be in the orange, etc. Next, you take the dice, only one. The other is extra except for the special rolls, and you have players take turns rolling the dice. The dice contain 1, 2, 3 only because you want the students to not skip through the entire game. It's a fairly small game, so that way they can have multiple different aspects in it. So this way students are able to really get the game going without going through it too fast. And then you'll have the players take turns rolling. The highest roller goes first, and the others fall in order after. So if one student gets 3 and another student gets 2, the student with the roll of 3 would go first, and the student with the roll of 2 would go second, etc. And if students have the same number, they just go off of who rolled first, basically. Which the example is listed in the instructions below of that part of the setup. The next part of the game guide is the time to play area, which is how to win. Throughout the game, everyone makes answers to the equations. If you get it right, you win the card, and the player who gets the most cards by the end of the path wins. How to play. And I wanted this part to be fairly simple while being detailed enough where students could actually understand what's going on in the game, and this way if anything happens throughout the game they can reference how to do your turns, so that way there's no ifs, ands, or buts about the situation. You just have it right there in front of you on how you can play the game. So during your turn, you start your turn by rolling the dice, and the amount you get is the amount you move on the board. Once you move, the color space you land on is the color card you pick up, and that card will have an equation or a problem for the student to solve. The player to the left of the student must pick up the top card and read the problem to them, because each card has an answer and a question, so the student will not see the answer, but they will hear the question or the equation that they must respond to. Once you find your answer, you must state it to the other players. If you are right, the card is yours. If you are not, the player to your right gets a chance to steal it. If the player to the right get it correct, it is theirs. If not, the card goes back to the pile, and the players continue. Certain cards have special rules for when the answer is correct. Follow these rules if you want to win the card. Once you follow the rules on the card when you receive the card or put the card back, your turn is done and the next player may take their turn. So based on however the card works for you, whether you get it correct or whether you get it wrong, after that whole scenario is done, the card can go back in the pile or go to you based on whether it's right or wrong, or go to the other player based on if they get it right or wrong, and then the turn goes to the next person. I figured that these little symbols, considering they go with the section, would be nice to have on the game guide to keep it bright and filled while keeping it simple enough so that way students don't get distracted by what's on the paper rather than their instructions itself. So I figured that the little cards, the multicolored cards, would stand out because that's part of the game, and then the dice would also stand out because that's how the dice are in the game itself. Rules of the board. This card and path tile is divisibility rules and absolute value problems, which is the red ones, and that's the card in the middle and represents the cards themselves, and then that's the tile, and that is how it is for all of them, except for the special role, which only has a tile. This card, which is the orange one, is the path tile that is prime and composite number problems, and the card that's prime and composite number problems. The yellow card is greatest common factor and least common multiple problems. The green is operations with integers and fractions. The blue is decimal and percent problems. And the black with the star is where it gets a little interesting. This means you get a special turn. You get the chance to roll both of the dice provided in the box, and if you get a number between 4 and 6 as the total of the two dice, you pick any card to have as your own. There's no need to answer unless you prefer to. If you do not get the roll, you pick any question and equation card, and that card follows the rules as normal. So if you pick that card, you do it as you normally would, where you get asked the equation by the player next to you, and you have to follow it, and if you get it right or wrong, that will depend on whether you keep the card or not. This way of rolling adds a little bit of a twist to the game, where the students can either receive a free card to try to win the game faster, or they get a chance to pick the type of equation that they would get to solve, so that way there's an easier chance of them winning the card. This adds the board game aspect of the game into it more than just the math equations. This adds a little bit more fun to make it more of a game rather than just practice, and I think that aspect makes it a little bit more fun for students. And the last page is for fun, joy, and practice in your math equations. And then I created a little tiny business to try to make it a little bit more legit for the game guide itself, to add that little effect that you'd have in an actual guide and instructions for students. And I added the smile to make it a little bit more happy and joyful for students. And I figured that this last page would really stand out in showing what the actual idea of the game itself is and what the point of the whole thing is. So I figured that this last page could represent the examples of cards that you could have picked up from the board game. I figured making a few would show the idea while not having it overwhelming for you to view. Each card in the game itself would have 30 different card options, but I figured that this would show the relative idea of the aspect of the game. So basically, the red cards would be divisibility and absolute value. So you would do what is 57 divisible by, and then you have 3, 7, 5, or 8. The student that is the left to the student's turn that it is would ask that question. The student would answer. If it's wrong, the person on the student's right would get to take a chance to steal, and if that's wrong, then the card goes back and the answer is not revealed. But if the student gets it right, the answer is revealed to them and they receive the card for themselves, either the original player's turn or the one to the right of them if they get it wrong, and etc. for each of the cards, unless you have the special roll as mentioned before. So the next would be what is the absolute value of -8, so the answer would be 8. And then you have what numbers are 45 divisible by, and the answer is 1, 3, 5, 9, 15, and 45. For when it comes to the cards of the game, there's no time limit. Students can take their time. That is where the practice part of the actual game comes in, where the students actually get the time to solve the problems and to try to win their card. If students would like to, they could make it more fun in giving each other time limit, but there's no actual time limit in the game or in the instructions for the students. And that will be considered for every card, but I tried to make the examples of the cards represent what the actual cards would be if there was 30 in each pack, and that would show that they're not too extensive of problems, where they're easy enough to solve, where it shouldn't take the student longer than 5 minutes to solve it, which would mean that the game would take up some time, so it's not a super quick game for students, but also not take up multiple classes. Like, it's easy enough where they are able to solve the actual problem. Next would be solve the equation, which is the absolute value of 2 minus 4 plus 8, which would be 10. I also think that there's no need for students to show their work in this. If they would like to show their teacher when they're playing the game in class, they can. But this way, the students don't have to focus on that aspect because it's more of a board game rather than practice. But this way, they get a little bit of both at the same time. I wanted to clarify that the special role doesn't actually have any type of card. You either just choose a card to have for your own, or you choose a card that you have to solve. I wanted to clarify that because that's a big part of the game, is just getting that little aspect in there, but there's no actual card that goes to that tile. So for the board part of it, I decided to make all the tiles in this just simple sort of format around the board, but in a good enough format that so that way it has a little bit of a twist and turn throughout it, and an even enough amount of tiles where there's not too much of one type of card or too much of another. I wanted to keep it fairly small because they are solving equations and solving problems, but this way they have a little bit of a varying time span rather than a really fast game or a really long game, as stated before. I added the pink diamond at the end to show where the game has actually ended, and the student that gets there first does not win. It's based off of how many cards you get correct. So I wanted that to be shown that it's you've just reached the end. That's not you winning, because if you would win, it would say you win at the end. And then I have these little tiny symbols around the game just to keep it a little bit more active, a little bit more imagery, and just popping students, but not too much, so that way they can actually focus on the game itself, so that way there's not too much going on. You want it to be fairly simple, so that way the students have an easier time going through the game itself. Back to the cards, I have for orange, it would be like, what is the number, and is it composite or prime for the majority, because it's asking about prime and composite numbers, and you want the students to be able to actually solve the problem and answer the problem without having too much difficulty. So I thought that that type of question would be fairly simple to answer for a student, but enough where they can really think about it at the same time. The green is solve the equation, and each card would be a different type of equation that involves fractions and integers. That way it's, again, fairly simple for the students to answer, but not too intense for them. And throughout it, you'd have different types of numbers and equations for them to solve. That way they have a little bit of easier and a little bit of harder and a little bit of medium. So that way they have different types of options to see where they are at in their learning. The yellow is what is the greatest common factor and least common multiple of numbers. So you have the different options and then the answer for the student. And then the blue is what is the percent and solving decimal equations. I figured that showing a little bit of each side of each aspect of each card would really show the different sort of responses that students can have and the different sort of equations that they'd have to solve, just to show a variety of what would be in the actual board game itself. Overall, I really enjoyed this assignment and really enjoyed creating the board game for students, because I think that I've never done this before, and I think that this is a very interesting way to create something for your students, because this is actually something I could use in the future if I wanted to as well, is create a little game for myself to use for my students. And I just think that overall this was very beneficial to try to see what I could come up with, see where my creativity would bring me, and see what equations I could come up with based on what we've learned throughout this course. So overall, I really enjoyed this assignment, and I hope that you enjoyed seeing what I've created. Thank you very much.